Look up at the moon, and you'll see big dark shapes splashed across its face. Oceans without water, shadows that never move. For centuries, people imagined seas, forests, even a face staring back. Here's the simple truth. Those dark patches are real places with a violent past. And once you know their story, the moon will never look the same again. Today on Lies and Legends, we break down the top 5 facts that finally explain the moon's dark patches. What they are, how they formed, and why they're mostly on the side facing us. Fanfreyev. They're not shadows or water. They're ancient lava seas, the Maria. The dark areas are called Maria, Latin for seas. They look smooth and dusky because long ago, huge impacts cracked the moon's crust. Later, runny basalt lava flooded those basins and cooled into dark rock. When sunlight hits that dark basalt, it reflects less light than the bright, bumpy highlands around it, so the seas look like permanent stains. Names you can spot with the naked eye: Mare Imbrium, Mare Tranquillitatis, Mare Serenitatis, Oceanus Procellarum. You're for 4. Basalt is darker because it's packed with iron, and sometimes titanium. Moon highlands are made of pale, feldspar-rich rock, anorthosite. The Maria, by contrast, are iron-rich basalts, often with minerals like ilmenite that contain titanium. More iron and titanium shades lower albedo. They don't bounce back much light. Astronauts brought these basalts home. In labs, they're visibly darker than highland rocks. That chemistry alone explains a lot of the moon's patchwork. Cert 3. Space weather keeps the seas dark. Even without air or rain, the moon's surface ages. Micrometeorites sandblast the ground. The solar wind implants particles. These actions break glassy grains and make nanophase iron, tiny flecks that darken soil over time. Result: old mare lavas keep their dark, brown-gray look. Bright highlands stay bright because their minerals are different and their surfaces get churned up in other ways. That's why the stains don't fade between nights. They're baked into the rock. Number 2. Why are most dark patches on the near side? Thinner crust pulls extra heat. The moon always shows us the same face. It's tidally locked. By a cosmic stroke of luck, or physics, the near side's crust is thinner than the far side. It also contains more heat-making elements, a region scientists call the procellarum creep terrain. Thinner crust plus more heat. Easier for lava to erupt and fill basins on our side. The far side got giant craters too, but its thicker crust blocked most lava floods, so it stayed pale and cratered. That's why the man in the moon is a near-side-only phenomenon. Number 1. The dark seas mark the moon's most dramatic chapter: impact, then fire. Most Maria formed about 3.9 to 3.1 billion years ago. First, titanic asteroids slammed the moon, digging basins hundreds of kilometers wide. Think Imbrium, Serenitatis, Crisium. Then, over millions of years, lava welled up from below and filled them, smoothing the floors into dark plains. Some basins hide mass concentrations, mascons, extra-dense patches of rock under the Maria that tug on spacecraft and prove how deep and heavy those lava fills are. The dark patches are not just color, they're maps of giant wounds and the fire that sealed them. Quick field guide you can use tonight. Big round dark circle at upper left. Mare Imbrium. To its right, 2 linked dark ovals. Mare Serenitatis and Mare Tranquillitatis. Apollo 11 landed on the edge. The huge blotch on the left edge? Oceanus Procellarum, the largest sea of all. Mid-video challenge. When you spot the moon tonight, drop a comment naming at least 2 Maria you can identify. Can you find the Apollo 11 neighborhood on Tranquillitatis? Payoff. Why this matters now. Those dark basalts aren't just scenery. They may be resource hubs for future bases. Oxygen locked in ilmenite, iron and titanium for building, and smoother plains for landing. They also hold a clear timeline of the moon's last big breaths of volcanism. Read the dark, and you read the moon's true history. Summary: simple and strong. Dark patches: ancient lava seas in giant impact basins. They're dark because of iron-rich basalt and space weathering. They're mostly on our side because the near-side crust is thinner and hotter. Names matter. Learn a few, and you can read the moon by eye. If this made the moon's face finally make sense, share your favorite Maria below. And subscribe to Lies and Legends for more clear, mind-bending science stories you can see with your own eyes.